Hello, dear students. I am Samir Velankar. I welcome all of you to this first video on the topic infix, prefix, and postfix expressions. Actually, this topic comes under applications of stack, queue, and binary trees. We have seen stack, queue, and binary tree under data structure. And we saw stack is last in, first out, queue is first in, first out, and binary search tree is very best data structure for searching. But then here we will learn a very good application of these data structures, application of stack, queue, and binary tree. So I will suggest all of you not to see this topic only from the point of view of expressions. Well, this topic has been added or is taught tell you what is the importance or where can you apply this stack, queue, and binary tree, which variety of problems can be solved using these data structures. Let's come to definition. Now, any expression, mathematical expression I am talking about, mathematical expression can be expressed in three forms, which are infix, prefix, and postfix. What are these expressions is very easy to understand. You see the first type of expression called infix. I have written an example here, a divided by b. Now you can see that the operator, that is division, is written in between the two operands. The operands being a and b, isn't it? A and b are the values. Values are called operands. So check the definition. In infix expression, operator is in between the two operands. So that is why in between. So it is called infix. In second type of expression, postfix, is where we first write the two operands a and b, and then finally we write the operators, that is division. Now ab slash that I have written is same as a upon b. The only thing is the way in which we have written it seems to be different. It is postfix, but the meaning remains same. It is a divided by b. So operator is after means post, after the two operands. And the third type of expression being prefix. Pre means before. So you can see that the operator slash is written before A and B, before the two operands, hence the name prefix. Now, any of these mathematical expressions, infix, prefix, or postfix, can be easily converted into the other form. So let's take an example. The example here is we would like to convert some given expressions and all the expressions are infix. Okay. See, we are given some infix expressions and we would like to convert them into postfix and prefix. So just go through this methodology, how to convert any infix expression to postfix first of all. Let's take this infix expression, a plus b into c. We want postfix equivalent of this. Now what you will do is, or you should do is, you should take that operator first, which will have highest priority in this infix. Repeating the priorities, you know precedences. Multiplication and division have high priority, but multiplication and division have same priority, equal priority, but their priority is higher than addition and subtraction. Now, addition and subtraction has lower priority, but the priority of addition and subtraction is equal. So, in case you have an expression like this, a multiplied by b minus c upon d plus e. Suppose this is the expression. Then multiplication and division. Multiplication and division have high priority. Then subtraction and addition. But multiplication and division have equal priority. Although both their priorities is higher, but they have equal priority and both appear in the expression. Then which operator you should evaluate first? Now rule states that you should evaluate that operator which comes first from the left hand side. So multiplication and division have competition, they have same priority. But then multiplication has been appearing first from the left hand side. So you will evaluate A into B. Let's call it as R, some result. Let's say R1. So what is now pending is R1 minus C upon D plus E. Now there are three operators minus, upon and plus. But you know that division have higher priority than minus and plus. So you must solve C upon D now. Let's call it as R2, some result. So we have R1 minus R2 plus E. Now the two operators pending are minus and plus, and both have equal priority. Remember, minus and plus have equal priority. Then which one will be solved first? Because both appear in the same expression. Solve that operator first, which comes first from the left hand side. So R1 minus R2 will be dealt with. We will get some result R3 plus E. And now finally R3 plus E will give us the final result R4. Just I revised the priorities. By the way, we are considering only four operators in this entire topic: plus, minus, star, and slash. As we proceed, we will add more operators, but that's not adventurous. Once you understand the topic with the four operators, there is nothing special about some additional operators. All right. So let's come back to the problem. What is the problem? We want to convert infix expression, infix, into postfix or prefix. Let's take A plus B into C. We want postfix of this. So take the part which has highest priority, that is multiplication, and convert it into this portion. You convert it into C. So what is B into C in postfix? It is A plus. I have left this part as it is, A plus. Postfix is BC asterisk. Isn't it so? Now I forgot to tell you one more thing. You are converting B into C. This is infix into postfix. This is postfix of this is BC asterisk. Now we will set up a rule like this. Whenever any infix is converted to postfix, we will write first operand first, then second operand. So we will write both operands, but in their order, and finally we will write operator. Why am I explaining all this is because B into C, any student would say, sir, you can write CB star also instead of BC star, because CB star means C into B. BC stars means B into C, and both B into C and C into B is same because multiplication is commutative. Although CB star is correct, I don't disagree. This is correct. But we will maintain this rule whenever any infix like B into C is converted into postfix. We will write first operand first, then second operand. So both operands will be written, and after that we will read. You will understand why I am telling you all this is what B upon C. This is infix. How will you write this in postfix form? It will be BC slash, isn't it? You will write first operand first, then second operand, and then you will write operator. Now, you won't say this is CB slash, I am sure, because CB slash will mean C upon B, and C upon B is not same as B upon C. Correct? Okay. So, coming back to this again, A plus B into C. First of all, convert B into C in postfix because it has highest priority. What we have is A plus BC star. Now, let's make a habit of marking this BC star in the square bracket, saying that now this BC star is a single operand now. This is one operand. Previously, we had two operands, B and C, separated by asterisk. But now it seems that we have converted B into C into postfix, and we have got BC star, and we will call this BC star as one operand. This entire thing, BC star has become an operand. Okay, now what do you have? Do you see again two operands that we now have in this remaining expression is A is an operand, and BC star is an operand, and the two operands have been separated by plus. So this is again an infix expression. So what will be the postfix equivalent of this? You write the first operand first, that is A. You write the second operand second, that is BC star. Remove the square bracket now. So A is the first operand, BC star is the second operand. Then you write the operator, isn't it? And now you see that the entire expression has been converted to postfix equivalent of A plus B into C is ABC star plus. Okay. Let's take the same infix expression A plus B into C, and we want prefix equivalent of this. So you will convert B into C first. It has highest priority. What is the prefix notation? Again you write operator first, operator star, then you write first operand, and then you write second operand. Mark it in the square bracket. This is one operand now. And now you are left out with A plus. Now what do you see? You see two operands again. A is an operand and star BC is another operand separated by plus. So what is the prefix equivalent of this? It will be operator first, that is plus, then the first operand, and then the second operand. Operand is star BC. Hence, this is the prefix equivalent of the given postfix A plus B into C. It is plus A star BC. Okay, let's go through the second example. We want to convert A into B plus C minus D upon E. Now, you see that multiplication and division have higher priority than addition and subtraction. But both multiplication and division have same priority. Then you will solve that first, which comes first from the left hand side. So you better convert A into B first. In the postfix will be AB star. Mark this has become one operand now. What remains is plus C minus D upon E. Now among plus, minus and slash will be dealt with first, having higher priority. So we get AB star, still one operand. This is one operand. Leave it as it is. Plus C minus, and we get DE slash here. Mark it as one operand. Now we have plus and minus. Both have same priority. Then plus comes first from the left. So now we have AB star as one operand, C as another operand, plus as operator. So the postfix notation will be AB star, first operand first, then C, second operand, then plus the operator. Mark it as one operand now, and what is remaining is minus DE slash. Now only minus pending. So you write the first operand. First operand is AB star, star C plus. Second operand is DE slash, finally minus. So this is being the postfix equivalent, you watch, of the given infix. Now let's write the infix again and try to find out the prefix. So A into B plus C minus D upon, A into B will be done. AB star becomes one operand. plus C minus, and we will do this also in this step, same step, instead of showing the line. You understand? Because anyway division will be done next. So DE slash becomes one operand. Now plus will be done. Your P star C. Oh, what am I doing? I'm so sorry. I lost my mind. I'm so sorry. Sometimes happens. I'm still finding postfix. Okay, really sorry. Okay, let's come back. Uh, A into B, A into B. Prefix of this will be star AB. Mark it as one of plus C minus, and now D upon E. Anyway, division will be done with multiplication. So this will be slash DE. Instead of showing one more step, we have shown it in this step. Now addition and subtraction have same priority. We will do addition because it comes first. So first the operator plus, then star AB, correct? Star AB, then C, the second operand. I hope you are understanding. Star AB is the first operand, C is the other operand. Let's mark it. Now minus slash DE. Now finally only minus remains. So you write minus first, the operator, then plus star ABC, plus star ABC is the first operand, isn't it? And the second operand is slash DE. Hence, this is the prefix equivalent. This is prefix equivalent given infix. Let's come to one more example. Here we have been given infix expression with bracket. You know, infix expression is characterized with one more symbol called open bracket and close bracket. And the importance of bracket is bracket can be used for superseding or for changing the priorities. So now you tell me in this expression, won't bracket A plus B get solved first? Instead of division and multiplication, although division and multiplication have higher priority, but plus, that is A plus B, have been given in the bracket, and you know bracket gets solved. Even C minus D and E plus F will be done before multiplication and division. So what will be the postfix notation for this? You will have to convert A plus B first. Agreed everyone? Put it. Put it as one. Division is remaining. And C minus D is also written in the bracket. So it will be CD minus. Do it in the postfix. And E plus F is also in the bracket. So it will be EF plus. Now we have got three operands as I am underlining. AB plus, CD minus, and EF plus are three operands. And we have got operators, division and multiplication have same priority, but then you will solve division first because it first comes first from the left hand side. So what will be the postfix? First operand first, AB plus, then second operand CD minus, and then the operator slash. Mark it as one operand now. What remains is into EF plus. And now multiplication will be dealt. So you write the first operand first. First operand is AB plus CD minus and then slash. And then you write second operand. Second operand is EF plus and finally write the operator. So this is the postfix equivalent of the given infix. Okay, let's write the same infix and try to find out what is the prefix for this. I hope you have got enough. Wait for this example so that I can tell you something more further. What is the prefix of this? Bracket solved first, so it should be plus AB. One operand now slash. Bracket solved first again C minus D, so minus C. One operand now into bracket solved first E plus F becomes plus EF. And now division and multiplication. So division will be done. So division followed by first operand plus AB followed by second operand. Mark it as one operand into plus EF remains. Now finally multiplication. So write multiplication, that operator first, then the first operand, and then the second operand plus EF. So this is the prefix equivalent of the given infix. Okay. So I hope you have enough of this. What is infix, prefix, postfix? How to convert infix into prefix and postfix? Now let's come to importance of postfix and prefix. I'm sure any student would think, what is the sense in writing any infix expression in postfix and prefix? Because since when we started learning math, we have been always writing any expression in the form of infix. Even in C program, whenever we want to write any expression, we will always write an expression like z is equal to a plus b into c, isn't it? Why will you write an expression as z is equal to a b c star plus, saying that this is postfix equivalent of the given infix? No, that means the importance and why we are learning postfix and prefix must be learned. Now, please try to understand that the postfix expressions, or prefix for that matter, postfix or prefix, are faster to evaluate, faster in evaluation. You can evaluate a postfix expression faster than the given equivalent infix expression. Let me prove it. Suppose this is the infix expression given, a plus b into c. You are asked to evaluate this. Forget about computer. Forget it. You as a person are asked to evaluate a plus b into c. Now on reading this expression from left to right, you will see plus first, but you will not operate plus, isn't it? You will not use plus because you know that there might be another operator having higher priority than plus sometime later in the expression. So you will keep reading the expression till you end it. And then after reading the entire expression, after scanning the entire expression, that B into C should be done first. So in one sentence, I can tell you that in infix expressions, the operators do not appear according to their application or the order. If you don't believe me, if you say no, sir, we are very comfortable in solving infix expression. What are you saying? Since high school days, we have been solving infix expressions. But you know what? I will give you an infix expression which is very big, 1 kilometer long. Just imagine an infix expression so big, 1 kilometer long, and I ask you to evaluate it. When you start scanning the expression from left to right, you get plus, you get minus, you get asterisk, you get slash, but still you won't apply it because you may be suspecting some bracket somewhere, isn't it? So you will have to scan the expression, and good lord, after scanning for a long time, after going long time, you get some nested brackets somewhere, and okay, oh my god, this addition, then this multiplication, then this slash shouldn't be solved because somewhere brackets are there. This should be solved first. So solving infix expression is bit challenging and time consuming. Please try to understand, which is not true with postfix. I hope I am talking sense and you're understanding what I am talking about. Even for human, if the postfix expression given, human can solve postfix expression faster than the infix expression. Let's see. Let's prove it. Let's prove it with a bigger example. See this example. The example number B, where the postfix expression given, I will write it again over here. A into B plus C minus D upon E was given. What you did is, as an infix operation, you will do A into B. After that, wait. You will say, I will not do plus, I will not do minus, I will do division. So operators are not in the increasing order from left to right according to their application. But now for this infix, you see the equivalent postfix that we already found. Postfix. The postfix that we found has been written here. The postfix is AB star C plus DE slash and minus. Try to understand what will happen if you are asked to evaluate this postfix. What you will do is you will scan the postfix from left to right, and the first operator that you get from left to right, that is multiplication, will be applied on just the previous two operands. Are you understanding? So what you will do is you will take the multiplication and you will multiply that with A and B, and you will get some result, R1. So now what is pending is R1C plus DE slash minus. And now you will keep scanning the expression from where you left out. R1 was already solved. And now you again get an operator, plus. Now this plus will be applied on C and R1. So what are you adding? You are adding R1 with C. And that is what you might have exactly done in the infix. You might have done A into B first. That's what we did, AB star. And then you would have added it with C. So R1 is getting added with C. We will get R2. And then DE slash and then minus remains. Now, when you keep scanning the expression from where you left out, you already evaluated R2. You get DE slash, but slash, the operator will now be applied on D and E. So D upon E will be done. Thank God, you see that there was minus. You check that there was minus in the infix, but you won't do minus. You will do D upon E first, and that's exactly what is happening in the postfix. So you will get R2 followed by R3, which is D upon E, and minus remains. Now R2 will be subtracted from R3 and we'll get R4, the result. This is what we would have done while solving infix. What you observed is A, B star, C plus, DE slash minus. This postfix was solved in one scan. We went from left to right and we didn't have to worry about, oh my God, is this the correct operator I am applying? Oh good Lord, is this the highest operator that we should apply? But then you will have to worry a lot when you do it for infix, because you don't know that the very first operator that you get from left hand side has to be solved first or not. There might be a higher priority operator at the end, but you note that in the postfix expressions, the operators have been arranged in the order of their application. Very interesting, isn't it? Very nice. Similarly, you see any infix. For example, you see this infix, the infix which we solved in the third exercise, A plus B given in the bracket upon C minus D given in the bracket into E plus F given in the bracket. This is so difficult to solve in the infix. Believe me, you will have to search brackets everywhere and say, no, division should not be done. Oh, no, multiplication should not be done. I should first solve the bracket. And all brackets hidden everywhere in the infix. But you see the postfix equivalent. So interesting that postfix notation does not have any hidden brackets at all. And you don't have to bother about whether I should apply an operator first or not. See this postfix. How interesting it would be to solve this. Very interesting. If you scan this expression from left to right, the first operator you get is plus, and plus will be applied on A and B, the previous two operands. So A plus B will be done first. Do you agree? This is what we have done in the infix also. A plus B was in the bracket. Now R1 is done, and what we are left out with is CD minus slash EF plus multiplication. Now, if we keep scanning the expression from where we left out, R1 is already solved. Then CD minus, so minus has been encountered. So C will be subtracted from D. This is what we would have done in infix. because C minus D was written in the bracket. So R1 and R2 is the result. R2 is the result of CD minus. And what is now pending is slash EF plus multiply. Now slash, if you see from where we left out, slash will be applied on R1 and R2. So going back to infix, A plus B upon C minus D is getting done now. So interesting. R1 is nothing but A plus B, R2 is nothing but C minus D. Both are getting divided. We will get R3. And what is now pending is EF, sorry for this, plus and then asterisk. Now if you start scanning from wherever we left out, R3 was already solved. EF plus will be done now because plus is the operator. So we get R3, R4. And finally multiplication, we'll do R3 into R4 to get R5. You have to agree, rather you must have agreed that postfix expressions are faster to evaluate than any infix expression. Same goes for prefix also. Prefix expressions are really fast to evaluate as compared to infix. Although that has not been discussed in this video, we will discuss about prefix expressions in detail in coming videos. That's what I have written as far as importance of postfix and prefix is concerned. See that postfix or prefix expressions are faster to evaluate as compared to infix. In both postfix and prefix, the operators appear in the order of their application or evaluation from left to right. You don't have to bother about can I apply the operator now, isn't it? They are already arranged in the order of their application. Rather, any infix expression written by C programmer is converted to postfix form by the compiler. Or really, that means we are under an impression that an infix expression written by me like this in my C program gets solved as infix. No, never. This infix is converted into postfix ABC star plus by compiler. Compiler keeps this postfix notation. And when the program runs, infix doesn't get solved, but postfix gets solved because this is faster in evaluation. Very interesting, isn't it? Okay, now the next topic is expression tree under the same chapter, which we will see in the next video. Thank you very much.